Hello, in this video we're going to discuss how to perform polynomial division or division of polynomials. They are synonymous terms. So before we go into polynomial division, I want us to go back and to remember our inner grade schooler. I want us to go back and remember our inner grade schooler, and I think that will help us substantially when learning how to perform polynomial division. So let's go ahead and say that I wanted you to divide 13 into 1,478. So let's say we want to divide 13 into 1,478. So going back to our inner second grade or third grade or whatever grade that was when we did this, we would say, does it divide evenly into 1? We said no, and probably in second grade we put a 0 above the 1 indicating that it didn't go into the 1. The next thing we determined was does 13 go into 14? And we said, yes, it does. How many times evenly? We screamed 1. And then once we took that 1, and we multiplied it times the 13. We multiplied it times the 13, and we got that value of 13. We got this value of 13. But remember, we had to subtract this value. We subtracted, let me use a different color there. We subtracted this value. Make it a little bit brighter. We subtracted that value, and then we got a remainder. We got a remainder here of 1. And we used to check. We could determine if 1 was less than 13. If it was, we were pretty much on a good track. We checked to see if 1 was less than 13, and since it is in this circumstance, I feel safe that we chose the correct multiple. The next thing we did was we brought down this 7. We brought down this 7. And I asked the question, especially when I teach this, why do we bring down the 7? And most people usually hum and haw. I remember the reason why I did it was because my second or third grade teacher, she told me to. So I had a woman that taught me second grade math, and I had another really nice lady that taught me my third grade math, and they both told me to bring down that next value, and I did it, and we screamed it in class, and we usually got rewarded or a sticker for doing it. So now, we started from the beginning. We started our process from the beginning. Does 13 go into 17? And we said, yes, it does. And how many times does 13 go into 17? We said that it goes in a value of once again. It goes in a value of once. One time. So then we took that 1 and we multiplied it again by our divisor, and we got a 13 here. And the next thing we did was that we subtracted the 13. And I often ask my students, why do we subtract that 13? They hum and haw, and usually the response that eventually I get was because we were told to growing up. We were just told to growing up. So I bring down that 13, sorry, I bring down that 7, determine 13 goes into 17 once, and now we're going to subtract. We find this little remainder here to be a value of 4. And the next thing we did was that we brought down a value of 8, and we did that because we were told to. So the next thing we said is, how many times does 13 go into 48? And most of us usually screamed at this point. We said 3 times, and we would be correct. Let me change a different color here. I'll do this one and let's do it in pink. So we did this one 3 times. So we took the 3, start from the beginning again, multiplied times the 13, and we get 39. And of course, we had to subtract that 13. And we said, okay, how many times is 39? 48 minus 39 gives us a value of positive 9. We said positive 9. And that 9 is less than that 13, so that's a check for us. So in second grade, so I always like to do, so in second grade, we wrote our answer as 113 remainder 9. 113 remainder 9. In third grade, we advanced a little bit, and we said that we had 113, and we took our remainder and divided it by our divisor. So we divided it by our divisor. So we got 100. I'm sorry, I don't know why I wrote 111. It should be 113. It should be 113. Where's that color? I don't know which one I was using. I think I was using this one. There we go. 113 and 9/13. And then in fourth grade, usually what we did in fourth grade is that in fourth grade we usually added a decimal point, then added a 0, and then we continued on. In this same fashion. So we brought down that 0. So every grade advanced somewhat differently. For the meaning or for the procedure of polynomial division, I want you to remember your inner third grader. That is imperative for us to be successful in here. So don't remember your inner second grader, don't remember your inner fourth grader, fifth grader, remember your inner third grader. So before I continue with our inner third grader division, let us talk about the other way this could be written. We could have also written this division question as 1,478 all over a value of 13. That is synonymous with saying 13 divided into 1478. Those are synonymous terms. So now let's go ahead and perform an example of a polynomial division. So let us say that we wanted to take x squared minus 5x plus 6 all over x minus 3. So we're dividing it by x minus 3. So in our numerator here, we have a trinomial. In our denominator, we have a binomial, and we want to divide them. I always recommend converting this to our long division format. So this is the polynomial division. So we're going to take our x minus 3, and we're going to divide it into x squared minus 5x plus 6. So now we've set it up so we can perform our operation. The first thing that we do is we say what times x, and we're only going to look at our first term, gives us x squared. What times x gives us x squared? And hopefully we think, okay, what times x gives me x squared? That's going to be a value of x, so I write that x directly on top. And I know some people might write it over here. It doesn't make a difference where you write it, as long as you write it somewhere up on top, and we keep going in descending order. So we said, what times x gives me x squared? And that was a value of x. So going back over here, once we determine this value of 1, our other problem, we multiplied it times our entire divisor. So now what we're going to have to do with this x is that we're going to multiply it times the entire divisor. We're going to perform the same algorithm. So we're going to take x times x gives me a value of x squared. We're going to take x, and this is going to be times a negative 3, and we get a negative 3x. We get a negative 3x. So next thing we did over here, remember, is that we had to subtract. And we subtracted that entire value of 13. So guess what we're going to have to do over here? We are also going to have to subtract. But when we subtract, we're going to subtract the entire quantity. We can't just subtract the x squared. We have to subtract the entire quantity. So what does that do? That's going to change the sign of the x squared to a negative, and that's going to change the sign of the 3x to a positive. So I'm going to indicate, let me erase that by putting a little bit left. So I'm going to put it over here. There we go. A positive 3x. We change our signs internally. So now we recognize that the x squared minus the x squared gives me a value of 0. So this right here cancels. Negative 5x plus 3x gives you a value of negative 2x. Gives you a value of negative 2x. And what do we do next? We had to bring down that 7 over here. Remember how we brought down that 7? We're going to do the same thing over here. We're going to bring down this value of positive 6. We're going to bring down that value of positive 6. And then we start from the beginning one more time. We said, so we'll do this next iteration in orange. What times x gives me negative 2x? What do you multiply x by that gives you negative 2x? And that is a value of negative 2, which I'm going to write directly up on top. And once we determine that value, we're going to have to do the exact same thing. We're going to multiply it from the beginning. So negative 2 times x gives me negative 2x. Negative 2 times negative 3 gives me a value of positive 6. Positive 6. But remember what we have to do. We have to subtract this entire quantity. We have to subtract this entire quantity. So if I subtract this entire quantity, I'm going to go and change the signs, and I'll do it in purple this time. A negative times a negative here will give me a positive. And a negative times a positive gives me a negative. So I like to circle my signs so I know which one trumps the other. So my negative 2x plus 2x cancels, and the 6 minus 6 cancels, and notice here we get a value of 0 at the end, and this is our, I don't know what I wrote B for, this is our remainder. This is our remainder. So we say that this will go into, x minus 3 goes into x squared minus 5x plus 6. It's going to go in there x minus 2 times. X minus 2 times. And notice, think about this. If we want to check ourselves, 6 divided by 3 equals to 2. 6 divided by 3 equals to 2. And we can check that because we know we can take 3 times 2, and that has to equal to 6. The same idea works here. If I take that x minus 3 and I multiply it times x minus 2, that will fold together to give me x squared minus 5x plus 6.